So now we're going to have a go at answering these example questions on the right. And the one thing that we have to remember and keep in our minds throughout this whole process is the one equation, pH equals negative log to the base 10 of the concentration of hydrogen ions. This is especially important because it reminds ourselves of the fundamental definition of what pH is. It's all based on the concentration of hydrogen ions in a solution dissolved in water. So in this way we could define an acid, and it is defined. The acidity of something is defined by its ability to donate H+ ions, so it's very important to keep this, and you'll see how this affects an actual substance's pH as we complete these questions. So we have our first question. Given that the pH of a beaker of water is 7, work out how many H+ ions there are in 1 liter of water. Now we know we are given some information at the start. We know that its pH is 7, and we know that there's 1 liter of it. So let's try just to substitute pH into the equation first. We have 7 equals negative log to the base 10 of the concentration of H+ ions. If you remember, this concentration once more is given as moles per liter, or dm cubed. I suppose we can put the negative on the opposite side. Negative 7 equals log 10 concentration of H+ ions. We can then rewrite this as the concentration of H+ ions is given to be 10 to the power negative 7 moles per liter, like that. And we're trying to work out how many actual H+ ions are in 1 liter of water. Now, we know that there are 10 to the power negative 7 moles of it in 1 liter, so I guess we can cancel this out. So we know that for 1 liter of water, there are 10 to the power negative 7 moles of H+ ions. So right there is our solution. If we wanted to give an actual empirical answer, it would be 10 to the power negative 7 multiplied by 6.02 times 10 to the power 23, Avogadro's constant, the definition of a mole. Okay, now our second question. A strong acid, actually no, let's start off by rewriting this equation on the top just so it's fresh in our minds. pH equals negative log to the base 10 of the concentration of H+ ions. A strong acid has a pH of 2. If 1 liter of the acid is diluted with 1 liter of water, what is the pH of the resulting solution? So once again, we're given specific information to the question right off the bat. We know that its pH is 2, so let's try substituting that in. Doing the same thing we did last time, we could just simplify it to negative 2 equals log 10 to concentration of H+ ions. Therefore, the concentration of H+ ions in moles per liter, it's very important for this question, equals to 10 to the power negative 2. So we see that this is comparatively higher to water, much larger compared to water. Water was 10 to the power negative 7. So we can see that a larger amount or concentration of H+ ions in solution generates a more acidic solution, because solution of pH 2 is more acidic in comparison to a solution of pH 7. So we know that this acid has a concentration of 10 to the power negative 2 moles per liter for hydrogen ions. So it says that it's diluted with 1 liter of water. What is the pH of the resulting solution? Now, what we actually have here is a unit for concentration, moles per liter. Now, we know that we have 1 liter of acid and 1 liter of water. So if we took 1 liter of acid and added 1 liter of water, we'd be left with 2 liters of solution. Now, taking our original value, 10 to the power negative 2, this is given in moles per liter, but here we actually have 2 liters of solution. So we want to convert it back into the original unit of moles per liter. So if we took 10 to the power negative 2 and divided it by volume, given in liters, we would be left with 10 to the power negative 2 over 2 moles per liter for this specific solution. So now if we wanted to find the pH of the resulting solution, we'd use our first equation, bring it all the way back down. We'd find a pH is equal to negative log to the base 10 of whatever this value was, our concentration of H+ ions. 10 to the power negative 2 over 2. And I think if we plug this into a calculator, we get the answer, pH of 2.30 to 3 significant figures. Okay, so now we're done with this question. And next, we'll go on to the next one, I suppose. We have a strong acid has a pH of 1.3. If I have 100 milliliters of this acid, how much water needs to be added to create a solution of pH 2? So it's sort of the previous question in reverse. And right from the start, we have a pH given to us again. So let's write our equation at the top. pH equals negative log to the base 10 the concentration of H plus ions. Now we know pH equals 1.3, therefore negative 1.3 equals log to the base 10 concentration H plus ions. Same thing, therefore concentration of H plus ions, once more very important, it's given in moles per liter, is equal to 10 to the power negative 1.3. Now we have, how much do we have? We have 100 milliliters of this acid. So if there were 10 to the power negative 3 moles of it per liter, how much would we have per 100 milliliters? I suppose we'd have to divide by 10, because we know that 100 milliliters is the same as 0.1, liters. So let's divide this by 10. We have 10 to the power negative 1.3 over 10, and we know using indices rules that is the same as writing 10 to the power negative 2.3. And the question is, how much water needs to be added to create a solution of pH 2? Now we know from our first general formula that pH is defined as negative log to the base 10 of the concentration of H plus ions. And if we had to create a solution of pH 2, we would need this H plus value to be equal to something that would give us a resulting value of pH. So let's try this out. I want pH to be equal to 2. Therefore, negative 2 will equal to log 10 H plus ions. And therefore, we can rewrite the concentration of H plus ions that we desire to be equal to 10 to the power negative 2. Okay, now, the question was, how much water needs to be added, so I guess diluted, to create a solution of pH 2? Now, we have our original value of 10 to the power negative 2.3 moles of H plus ions, and we know that dividing this by a volume will give us a concentration. We want to find this volume that will give us this resulting H plus concentration of 10 to the power negative 2. So we do 10, segregate this, we have 10 to the power negative 2.3 over volume given in liters as its concentration equals to 10 to the power negative 2. Rearranging this gives us volume in liters equals 10 to the power negative 2.3 over 10 to the power negative 2. And I think this gives us an answer of 0.501 liters, which is the same as writing 501 milliliters to 3 significant figures. Now, moving on to our final question. Okay, I think this is mixing question. 400 milliliters of an acid of pH 3 is added to 300 milliliters of an acid of pH 4. What is the resulting pH? Okay, let's follow the same steps and we should get to a conclusive answer. We have pH equals negative log to the base 10 of the concentration of H plus ions. Now, let's take solution 1. We have 400 milliliters of an acid of pH 3. Now we substitute. We know that negative 3, because that's its pH, equals log to the base 10, concentration of H plus ions. Same rhetoric. The concentration of H plus ions equals to 10 to the power negative 3 moles per liter. Now we know that we have 400 milliliters of this acid. So if this is the amount of moles per liter, we know that the amount of moles of H plus ions in this acid will be 10 to the power negative 3 times 0.4 moles. So this is solution 1. Now if we go on to solution 2, we have it given to be pH 4, so we do the same thing. Therefore, its concentration of H plus ions will be the same as 10 to the power negative 4 moles per liter. Therefore, the amount of actual H plus ions in it will be 10 to the power negative 4, and because we have 300 milliliters of it, times 0.3 moles. Now, this is solution 2. To actually work out the resulting pH of our combined solution, what we actually need to do is once again bring in this star equation that has been following us through this whole time. Now, this is given as the concentration of H plus ions. That will give us a pH. So let's try to find this concentration. We have this many moles and this many moles. So let's get a new color, and let's add 1 and 2 together. This actually gives us, if I get this right, gives us 1 plus 2 gives us 0.00043 moles of H plus ions. Now, what else do we know about this? We know that solution 1 get another color, has 400 milliliters of acid within it, and solution 2 has 300 milliliters of acid within it. This gives us a combined total of 700 milliliters. Now, this is the same as saying 0.7 liters. So once again, we divide the amount of moles by liters to get a concentration. So divide this by 0.7. That will leave us with approximately 0.000614. We substitute this back into the original equation. Let's make some space. Okay. Therefore, pH equals negative log 10 of this concentration, 0.000614, which is the same as saying pH of approximately 3.21. Okay, there we go.